Hello and welcome to program 2 of this video channel on the climate emergency and spiritual values. I'm Chris Philpott. This is my YouTube channel. When we talk about the causes of climate change, we can talk about the physical causes, which is what people mainly think about. But do they understand them? People talk about climate change, but what does that mean? Well, it's not weather. Climate change is the change of weather over a long period of time. So there'll be changes of temperature. We've seen the heat going up. There's changes in rainfall. We've seen the floods rising. There's change of wind speed. So we have hurricanes. Really, the climate system is based on the idea of balance. Incoming energy from the sun against outgoing energy from the earth that reflects the energy of the sun. Let me explain if you look at this diagram. Firstly, the sunlight comes in on number 1 in the form of infrared radiation. It passes through the atmosphere and warms the earth. And number 2, secondly, this infrared radiation is then given off by the earth, so the earth reflects it back. And thirdly, if you look at number 3 on the diagram, most of the heat escapes into space. But if you look at number 4, some of that heat doesn't get back into space. It gets trapped by what's called greenhouse gases, such as carbon dioxide. Right, we're talking about greenhouse gases trapping heat. It's like this blanket. If I put it around my body, I'm trapping the heat. So the heat can't get out of my body, and therefore I keep warm. So they don't allow the heat to escape. Now this is fine, absolutely fine, if there's a balance of energy coming in from the sun and energy coming out. Now if we didn't have those greenhouse gases that act like a blanket, the temperature on Earth would be minus 18 degrees centigrade, which is a lot of like these frozen planets. So there wouldn't be life on Earth. So we need the greenhouse gases. But if you got too much greenhouse gases and the heat can't escape, then the temperature goes up. Now at the moment, things are balanced. The average temperature around the globe is plus 15 degrees centigrade. But what happens if you have this blanket? I'll put it around me and I put another blanket. I'm going to get very hot. I'm indoors, I don't need to be that hot. So the thickness increases as the trapped CO2 increases as the more layers of greenhouse gases accumulate. This is a cumulative process. It, rather like the layers of onion, it just gradually one layer, then one layer, one layer. But if you look at this short video, it recapitulates what I've been talking about.
This is Earth, the planet in our solar system that we live on. However, our planet is not on a good path for continuing to sustain life. The Earth is facing the accelerating detrimental effect of climate change, also referred to as global warming. Well, what exactly is climate change? Climate change is defined as a long-term change in the Earth's overall temperature with massive and permanent ramifications. Climate scientists believe that this isn't caused naturally by the Earth, but by human activity. Earth's atmosphere consists of gases such as oxygen and nitrogen, and other gases known as greenhouse gases like carbon dioxide, nitrous oxide, and methane. Incoming light from the sun hits the Earth's surface. The Earth absorbs some of that energy, heating the surface of the planet. The rest of that energy gets reflected. Some of that energy goes back out into space, but greenhouse gases like carbon dioxide trap the energy and send it right back to the Earth's surface, heating it up even more. This is known as the greenhouse effect. Now, a little greenhouse effect is natural to the Earth and is a good thing to have, but a large greenhouse effect can be catastrophic, causing a lot of that energy to stay in our atmosphere and heat up the Earth at an accelerating rate. Some of the main human activity that emits greenhouse gases are fossil fuel burning, animals, agriculture, and deforestation, and waste and recycle pollution. Burning fossil fuels like coal, oil, and natural gas, as well as gasoline, are some of the largest pollutants of carbon emissions.
Well, basically, we're the cause of climate change. Growing numbers of us, humans, have things that cause greenhouse gases to increase. Like looking at this car. This is industrial production. There's energy production to produce electricity, burning fossil fuels. There's deforestation. As we know, trees absorb carbon dioxide. If we cut them down, there's no trees to absorb carbon dioxide, so carbon dioxide goes up. There's transport itself, cars. They're run on fossil fuels, petrol. They produce carbon dioxide. When we produce food in agriculture, we've got that producing carbon dioxide because the tractors burn fossil fuels and the fossil fuels cause the greenhouse gases. So we've got also in your home now heating. Heating can produce greenhouse gases because your source of energy might be from power plants using fossil fuels rather than renewable energy. So all this adds up, and the level of greenhouse gases now are almost up a third since the pre-industrial levels. So what happens to this carbon dioxide? It's going up into the atmosphere, but it doesn't go away. It stays there for hundreds of years. And as we emit more carbon dioxide, producing more greenhouse gases, the temperature goes up and up and up. As we are the cause of our activities in industrial production I mentioned before, the great thing that drives it is consumerism and the culture of consumerism, which is only recently come about. And guess what? Other countries in Asia, Africa, they want to follow us and have this consumer culture. But every product that is made has a price of greenhouse emissions, particularly carbon dioxide, into production, unless that's produced using renewable energy. So places like China, with massive industrial production of consumer goods, and we've all bought them, haven't we? Trainers, reduced things. It's happened in my lifetime where everything's made in China. But that production is by the use of power from fossil fuels. Let's have a look at some of these consumer products. Well, let's have a look at trainers, a Trainers, very common. They were fashion items. And I remember such a headache with trainers with my own daughters in the 80s, where they had to have a specific brand. But guess what? They were produced using a lot of labour, sweatshops in China, but they were produced. And of course they're thrown away and have to be replaced. A car is another must-have consumer goods. They're very expensive, use a lot of resources to produce. We should be moving really to a non-car transport system, which is possible. The computer, well, I couldn't make this without a computer. They're a big consumer good and they take a lot of fossil fuel power to produce. The phone, mobile phone, another headache, like trainers, children in school. When I was working in schools, got to have the latest mobile phone. And the contract ends and you replace it with another and another and another, and it's thrown away. All of this consumption uses energy which produces greenhouse gases like carbon dioxide. The fashion industry, people want to look good. So the turnover of clothes from cheap fashion houses, you buy them in the shops and then throw them away when you've worn them once or maybe not worn them at all. So that avid consuming of things like clothes, which are necessary but use a lot of energy and produce greenhouse gases. The consumerist lifestyle, as I said, is being copied as a model throughout the world, but it really is unsustainable if we're going to deal with climate change. The world, the atmosphere, everything's in balance. That's why we've got a habitable planet. I've been watching The Perfect Planet by David Attenborough and series, and it shows that everything is in balance. It's very balanced. What comes in terms of heat goes out. What helps is photosynthesis. We've heard about this at school. It's where plants absorb carbon dioxide. But there's also lots of plankton and other creatures in the oceans that absorb carbon dioxide. So usually, as I've said earlier in the video, there's a balance of carbon dioxide going. So enough absorbed, enough emitted, it's in balance. That happened probably about 10,000 years ago, where mankind developed fire. Then it was a bit of an imbalance. When we measure the carbon dioxide in the atmosphere, we measure it in parts per million. So little atoms, parts per million. And in 2019, it was 408 parts per million. But that is the highest it's been for 800,000 years. Now, it's rather like a bathtub. You fill the tub until it's at the right level, and then if you keep on filling it, it overflows. So the capacity for the natural world to absorb carbon dioxide is getting less and less. The oceans can't do it. We're cutting down the forest can't take up the CO2. Let's have a look at which countries produce the most carbon dioxide. China is of course the leader, with 30% of all carbon dioxide is produced in China. And as I said earlier, they became the great developing country because they produce cheap consumer goods, which we bought and I bought. Then the USA produces 14%, so not as much. India produces 7%, and Russia 5%, Japan 4%. The UK is not really featured in this, which is ironic because the Industrial Revolution was started in my country. Since 1751, the USA has emitted 400 billion tons of CO2. And the history of the emissions, which the UK would have a part, but the US have 25% of historical emissions. And in 2014, each American was emitting 16.2 tons per person. So what they consumed, used, everything, that's how much. I think the Industrial Revolution started in my country. We have a moral duty to lead the world in the forthcoming climate change talks, COP26 in Glasgow, and show that we can reduce our carbon emissions. Then we have another greenhouse gas, which people don't see as a gas. You remember when you boil your kettle, you get that vapour in there, water vapour, yeah, just water. It actually traps heat and stops it radiating back into the atmosphere. With more moisture, the temperature goes up, which creates more moisture and more moisture and more moisture. So the atmosphere is becoming more saturated with water. Another greenhouse gas is one we are very good at producing, nitrous oxide. 40% of that comes from human activity. It produces 6% of the greenhouse gases. 2/3 of the nitrous oxide is in fertiliser. When I worked on a farm, they called it bag muck. Now, nitrogen's the main part of this component of fertiliser. And of course, with the Green Revolution, we can feed, that happened with agriculture and fertilisers and seeds in the 70s, we can feed more people. But population is an issue with this because the more people you have, the more fertiliser you've got to use to get more food. So that's a bit of a vicious cycle. And then nitrous oxide is found in traffic fumes, exhaust fumes, from the combustion of fossil fuels. So that's something we have all over the world. Until we get electric cars, that's going to, having a car, if it's not a hybrid or electric, you're going to be contributing to nitrous oxide as a greenhouse gas. Then we have a gas called methane. Now this is very easy to describe because it's often called marsh gas. So when you go to a marsh, you can smell this smell. And what it is the decomposition of biomass. There's no CO oxygen around, so it has this decay which produces methane. Again, it's important because it traps 25% more heat than carbon dioxide. And 50% or 60% of emissions of methane come from human activity. And if you eat meat or you have dairy products, then that obviously comes from a cow. And a cow is a group of animals called ruminants. Funny name, but really what it means is that the animal has lots of stomachs. And because of this digestive system, it produces a lot of methane. We often say cows and animals fart. Well, that's methane. When you fart, it's methane. So that's a problem. Also a problem is all the waste, and you can see this in lots in America where there's cattle ranches, cattle lots they call them, thousands and thousands of cattle, but they don't know what to do with the poo. Basically it causes a lot of pollution. So the feces of pigs and chickens also be raised for meat, that causes methane. So actually eating meat or dairy products, you know, that produces more methane. So maybe you could look at your diet. We'll talk about that later, but that's the source. Another thing is, we talked about consumerism, but where does all the rubbish go? Well, some of it rots down in landfill sites. And sometimes people are clever. The methane coming off, you can harvest it to make energy. There's a wildlife park near where I live where they've got a methane plant stuck. They take all the methane off the landfill site and use it for energy. Another way of producing methane is by fracking. What do we mean by fracking? That's a way of getting gas out of the geological structure underneath by cracking it. You force sand and gravel down into the cracks and it forces the gases out using a lot of chemicals. But of course the methane escapes in the process of getting the gas, but also in relaying it in the pipelines. And methane emissions in North America have gone up a lot because of the fracking revolution in the States. The most worrying though, in a long-term sense, is a source of methane in the Arctic. There's lots of methane that's trapped, frozen solid, in a form called methane hydrate. Now when this melts, it releases the methane. The ice melts, releases the methane. It's no longer encapsulated in ice, so it goes to the atmosphere, and there are trillions of tons of methane trapped in the Arctic. And it's already worrying that they're finding, looking at Siberia, which is warming quite rapidly, there's these sudden pools appear where there's lots of methane bubbling up. You can see it. So that's another source in the future. If we don't deal with climate change, that's going to become, again, cumulative, more and more. The last source of greenhouse gases is fluorinated gases. Fluorinated gases. And we'll show you what these are, where they come from. You can find these fluorinated gases in these products. For instance, coolants, like antifreeze. They're used in fire extinguishers, which you see everywhere. They're used in solvents. For instance, here's a bottle of white spirit you might use to clean brushes when you're decorating. They're used in pesticides, these substances that keep pests down on crops. They're also used in aerosols, like deodorant sprays, propellants. The gases are used as the propellant of the liquid in the container. These fluorinated gases are very, very potent, thousands of times more potent than carbon dioxide in heating. the atmosphere. And the trouble is they last for a long time in the atmosphere. So we really need to try and stop these products being used. Well, this concludes the causes of climate change. Hope you understand it more fully, because often it's cloaked in a lot of scientific language. But in the end, it's based on basic principles. And if you learn anything from this presentation, the buck stops with us. It's not the natural world that's causing the climate emergency. It's us by our activities. So we can change our behaviour and therefore change the outcome of climate change. I'll just say this, an important word to understand is cumulative, accumulating over time. The weather and the climate we have now is the product of what we put into the atmosphere in greenhouse gas emissions some years ago. And what we're putting in now will have an effect for perhaps a few decades in the future. So if we look at causes, the climate change basically is carbon dioxide and these other emissions. We've got to stop emitting them from now or as soon as possible. To delay or stop the effects later on. This is part of the problem with climate change. We're in a society, particularly in the West, where there's immediate gratification, immediate effect, immediate access. But climate change must be understood in its causes as having a long-term effect. And if anything you take from this video, it's to learn about that long-term effect. That we will cut emissions now, but we still have the effects for some years to come. But the sooner we cut them, the better. Thank you.